Okay, so today we'll proceed by looking at Cramers Rule, how to solve systems of equation using Cramers Rule for 2 by 2 matrix. So first of all, this is the format for a linear equation. A1x plus b1y equal to c1, and then a2x plus b2y is equal to c2. Then when we are using Cramers Rule, the thing that comes in our mind, sanande upanga solve it, we need to have the knowledge of determinants, how to find the determinant of a 2 by 2 matrix. Ngati tikudziwa kupeza determinant ya 2 by 2 matrix, then we are good to go. Nde tingofotokozerana kuti kodi kuti tipeze the value of x or the value of y imapanga bwanji. I know there are many methods of solving this type of equation, by substitution, Gaussian elimination method, Gaussian Jordan elimination method. Process on but our concentration now will be by using Cramers Rule. Then tikaona mene iliri my equation awiri, we can form a matrix from here. For example, we'll use the coefficients of these variables. For example, we have a1, b1, a2, b2. So we have a1, then we have b1, then we have a2, then b2. So this is the matrix that we have formed from this equation. And from here, we can find the determinant of this matrix. Now, okay. Now, how do we find x? So the value of x is found by dividing dx over d. Then y is found by dividing dy by d. So this d is the determinant. I mean, this is the determinant. Then it means it is required for us. We need to find all the determinant of this equation. Then we'll find the dx, then we'll find the dy. I'll explain how we can calculate dx and dy. Okay. Then you say guys. Okay. So we want to find x. If we want to find the D we said is a determinant. Determinant nanenera muja kuti we have A1, B1, then A2, then B2. So this is our matrix. These are the coefficients of the variables. So we have these variables, these coefficients. Then my coefficients are many and I mean I form a matrix here. Now to find the determinant, we said that it's you subtract the product of this diagonal minus the product of this diagonal. As I hope alias ababa kuzitolera bino bino. Let's see B2 minus A2 times B1. There will be these are determinants. But now to find dx, the dx, what we do is we form a matrix, a 2x2 matrix. Now, because we want to find dx, we have an x here. It means the coefficient of x will be replaced by the results of this equation. For example, here there is a1. If you are to find the dx, it means a1 will be replaced by c1. Then a2 will be replaced by c2. So in our matrix, we had a1, b1, a2, b2. Now, because we want to find the dx, what we're going to do is we're going to replace this a1 by c1 and this a2 by c2. So our matrix will look like this. It will be c1, b1, then c2, then b2. So from here, we can calculate now the determinant of this, which will be c1 multiplied by b2 minus c2 minus b1. So c2 times b1, not b minus. So here, when we multiply c1 by b2 minus c2 by b1, we're going to get dx. Now to find the dy, what will happen now is we'll have this one, a1, a2, a1, a2. But because we want to find the dy, the coefficient of y will be replaced by the results. For example, here we had a1, b1, a2, b2. It means where there is b1, there will be c1. Where there is b2, there will be c2. So it means here we have c1, then c2. So to find the determinant of this matrix is to say a1 times c2 minus a2 times c1. So whatever we get from here, the result will be dy, and the result of this will be dx. so let's see how we do solve with an example. Example 1. Okay, so let's say we are given 2x. We are given 2x plus 5y is equal to 7. Then the second equation saying 5x minus 2y is equal to minus 3. Okay, so for example, we are given this scenario, and they're saying solve for x and y. Now, to do that, we have seen that to find x, we say dx over d. To find y, it's dy over d. But the first thing, we need to find the determinant. So the determinant will come from a 2x2 matrix by using the coefficient of x and y in both equations. So you see the coefficient of x here are 2 and 5, and the coefficient of y here, coefficients of y are 5 and 2. So it will be 2 then 5, then 5, 2. So this is our matrix. So to find the d, which is the determinant, it will be 2 times 2 minus 5 times 5. So the 2 here is negative. We forgot to include the negative, so this one is negative. So it will be 2 times negative 2 minus 5 times 5. So it means we're going to get our determinant. So it will be 2 by negative 2 minus 5 times 5. So it will be, if we simplify here, it will be negative 4 minus, we have 5 times 5, which is 25. So negative 4 minus negative 25, it's negative 29. That means our determinant here is negative 29. Now, let's find dx. Let's find dx. So to find the dx, first of all, we need to construct a matrix. So to find the dx, we said that where if we have an x here, dx, it means where there is x, the coefficient of x will be replaced by the results of the equations. So you have 2 will be replaced by 7. It means 2 will be replaced by 7, and then 5 will be replaced by negative 3. So we will have 7, then negative 3, then we'll have 5, and 2. Ndekuti apapa kuti tipeze determinants zichivuta. 2 uyu tisamaiwale kuti ndi wa negative. Ndekuti ikhala 7 times negative 2 minus negative 3 times 5. Tikapanga simplify apa 7 times negative 2 to be negative 14 minus negative 3 times this one will be 15. So it will be negative 14 plus, because here there's negative, so times this negative it will be positive. So it will be negative 14 plus 15, which is the same as 15 minus 14. It will be 1. The answer will be 1. So let's find dy. So dy, first of all, we need to construct the matrix. So we are saying dy. It means the coefficient of x will remain the same, but now when it comes to y, the coefficients of y will be replaced by the results of the equations. So here we have 2, 5. We have 2, 5. But now, this side, instead of having 5 minus 2, you have 7 minus 3. So we have 7 and minus 3. So to find the determinant, of this, it will be 2 times negative 3, then minus 5 times 7, which is 5 times 7. So if we simplify this, it will be negative 6 here, minus 5 times 7, which is 35. So it will be negative 6 minus minus 35. So the answer here will be negative 41. So we have found the determinant, the d. We have found the dx, then we have found the dy. So to find x, we said is dx over x over d. So dx over d. Dx over d. So dx is 1, while d is negative, so it will be negative. It will be negative 1 over 29. While y, we said is dy over d. Ndipo apa tapeza kuti dy wathu ndi negative 41, pamene d wathu ndi uyu ndi negative 29. Now negative, the negative about they will cancel. So it means we'll have positive 41 over 29. So what it means is the value of x is negative 1 over 29, and the value of y is positive 41 over 29. Twava ndimene timapezera Cramers Rule ndeizvi kuzotipanga simplify that is kufuna kuti chikhale cha simple khale chika mixed fraction whatsoever. But this is how we calculate or we solve the systems of equation using the Cramers Rule, but of a 2 by 2 matrix. So in the next session, we are gonna Cramers Rule involving the 3 by 3 matrix. Thank you so much.